We're going to be learning a little bit about the tangent function graph, and it is a drastically different graph than the sine and cosine function graphs. Very different features, very different shapes. And I put together a little squirrel scenario to help people envision what actually happens when you're working with the tangent function. Okay, so here's the deal. We have our demonic-looking squirrel here climbing up a pole. And we've got a person standing here. And specifically, we're going to be looking at the angle that the person is tilting his or her head up at the squirrel. So you can see your sight line basically looks like this. Let's say the squirrel is right here on the pole. You're looking at an angle of elevation of 30 degrees up at the location of the squirrel. Okay, so I think in the activity, I think I give you a distance from the pole that the person is standing, but it doesn't matter. You can use any 30, 60, 90 triangle and you can get the ratio between the sides. So, the big thing here is for example, maybe this side is, 6 radical 3 and this side is 6, or this side is 4 radical 3 and this side is 4, and so on. When you simplify that, remember that tangent is always the ratio between the opposite side and the adjacent side, okay? And I've labeled this as y over x, kind of using the unit circle definition here, but certainly you can use the SOHCAHTOA definition. And anyway, when you work that out, you end up finding out that the tangent of 30 degrees simplifies down to 1 over radical 3, which is the same thing as radical 3 over 3, okay? And then you can come back and you can make a 45-degree angle. And so the squirrel climbs up the pole, and now we've got a 45, 45, 90 triangle here. Here's a 45-degree angle. And so, maybe this side is 1 and this side's 1, or maybe this side's 5 and this side's 5. The point is, for a 45, 45, 90 triangle, the tangent of that 45-degree angle is just going to be 1, okay? And then the squirrel continues to go up the pole, and we get a 60-degree angle, maybe up closer to where the squirrel is on the pole now. Okay, and you find the ratio between the opposite side and the adjacent side. So maybe this is 5 radical 3 and this is 5, or maybe this is 10 radical 3 and this is 10. But when you find that ratio, the ratio ends up being radical 3 when you simplify it down. Okay, so if we come look at a table here, put this together. So when x is 0, the tangent of 0 is 0. By the way, you can look at the unit circle too. Remember, tangent is the y over the x. And so in the unit circle, that'd be 0 over 1, okay? And so tangent of 0 is 0. Of course, it wouldn't really be a triangle there because he'd just be looking straight at the pole. Tangent of 30 degrees is radical 3 over 3, which is about 0.577. Tangent of 45 is 1, which we just showed. Tangent of 60 is radical 3, which is about 1.73. So hopefully you can see these tangent values are increasing. I don't think we see any kind of pattern about the increase. Now, tangent of 90 degrees, okay? Well, there are a couple different ways you can look at this. First of all, just kind of the base definition here. Tangent is the y-coordinate over the x-coordinate, okay? So if you go to the unit circle, you say, oh, the y-coordinate over the x, that would be 1 over 0, which is undefined, okay? And that's kind of surprising, okay? So it turns out the tangent of 90 degrees is undefined, but the question is, what exactly is going to show up on the graph? Like, what's that going to look like? Is there just a gap in the graph? Is there some kind of feature on the graph? That sort of thing. So I wanted to go to the calculator and look at this. We'll come back and look at the squirrel, because the squirrel scenario is actually why I'm doing this. So I've got tangent in my calculator already. I'm in degree mode here. And I'm going to go to the table. And I'm going to start the table off at 60. And you can see the change in my table is 1. And we'll go take a look at the table here. So if you look here, watch these tangent values. So you've got your 1.73, which is radical 3 there for tangent of 60. And then notice as we keep going up, those values are increasing. And so, we're up to about tangent of 75 now, and about 3.5 something, 3.7, something like that. And anyways, we keep increasing here. You'll see we're getting pretty big values here as we start to get closer to 90 degrees, okay? And you can see here, whoa, we get 57 at tangent of 89, and then error message. That's your undefined value, Okay, so my question is, what's happening as we get closer and closer to 90? I'm going to go back to my table setup here, and I'm going to look at values very close to 90. I'm going to go in at 89, and I'm going to change the step in the table to 0.1, okay? And I'm going to come back here, and I'm going to take a look at the table again. So here we are at 89, okay? So the tangent value is almost 60 there. At 89.1, it crosses 63, 89.2, 71, then 81, 95, 114, 143. We're getting huge values as we get closer and closer to 90. Look at that, 572, and then we're undefined there at 90, okay? Well, I'm going to go back to the table one more time, and I'm going to start the table out at 89.9, and I'm going to set the step to 0.01. So we're going to get values really, really, really close to 90, okay? And I'll go back to the table again and we'll look at this. There's 89.9, 572, okay, 636. We're over 1,000 now at 89.96, 89.97, almost 2,000, 89.98. Look at that, we're at 5,000 now as we're getting really, really close to 90 degrees, okay? So what's happening here? Well, here's the idea. If you noticed, we're always comparing the ratio between y and x, okay? So it's always the height that the squirrel is up the pole divided by the length that the person is away from the hole, okay? So if you notice, when the squirrel was down here, the height was pretty short, and we were dividing by an x value that was bigger. For example, tangent of 30 was 0.577, which is less than 1, okay? Now that the squirrel's way up the pole, the y length is significantly longer than the x length, okay? And so that's giving us a bigger tangent value, okay? We ended up with tangent being almost 2 there, okay? Now, imagine that this squirrel continues to go up the pole, and imagine, for example, what like an 85-degree angle might look like. You know, we've got almost a vertical line here. I'm going off the board, okay? Imagine that's like an 85-degree angle or something like that. Suddenly, you've got a really, really, really long opposite side, and you've got a very, very short adjacent side, okay? So imagine what's going to happen if this person's looking up at a 90-degree angle. Think about what's happening. The person is looking straight up, okay? That side's never going to get to the pole. And as a result, you're never going to have a triangle, okay? Now, even at like 89.9, you know, you'll eventually be able to have a triangle that kind of connects, and if you extend that out far enough, it'd be over there on the other side of that table. But you can have a value. But at 90, you can't have a right triangle that's got a 90-degree angle here and a 90-degree angle over here. It's not going to be possible, okay? So that's why tangent of 90 is undefined, because you wouldn't be able to actually make a triangle. And the point here is that height, in comparison to the width, the height can get basically infinitely long compared to this width always staying the same. And as a result, that's where you're getting, you know, again, for like tangent of 89, you know, you can go way up and you can have a very long side here divided by a very short side there. And that's why a tangent of 85, tangent of 87, tangent of 89 are all very large values. And then at 90, it just totally cuts off, okay? As a side note, negative angles. You actually can think about negative angles in the squirrel problem. A negative angle would just be that you're looking down, okay? So like for a 30-degree angle, that'd be a negative 30-degree angle because you're looking down at a 30-degree angle. You can still do an opposite over an adjacent. The difference is that opposite side would read as a negative and your adjacent side would be the same. So you'll get the same values, except you'll have negative, like basically your y would be negative here. It would be negative 0.577. It would be negative 1, okay? It would be negative radical 3. And negative 90, he would be looking straight down at the ground, and basically it would go on forever as well. Negative 90 is also going to be undefined, okay? So, does that tell us what the tangent graph looks like? No. But it does give us a little bit of insight into it. Now, for angles beyond negative 90 to positive 90, you're really going to have to go with the unit circle. I don't think the squirrel scenario really works for those cases. But the unit circle definitions, y over x, will continue to give us trig values beyond 90 degrees and filling out a full circle. So anyway, we'll take a look at the overall tangent graph elsewhere, but I wanted to make sure that you had an idea of what was going on with the squirrel scenario, because I think it's a great description, it's a great illustration, I guess, of what we're talking about here, but maybe a little bit tough to figure out what I was talking about on the worksheet.